Howdy, this is a presentation of Agbami Oil Field. This is a 3D diagram of the field layout. It provides a visualization of the FPSO, which is a floating, production, storage, and offloading unit. The project details. The current status of this oil field is operating to offset the production decline. The oil field is located in the Niger Delta basin and it was discovered in 1998. Production began in 2008. Here is a pie chart for the oil field ownership structure. It is operated by Chevron, who owns 67% of the oil field. This presentation will cover the following topics: basin map, stratigraphic column, structure map, structural cross-section or seismic lines, type logs, the reservoir description, the reservoir map, and stratigraphic cross-sections, as well as data that can support volumetric calculations. This basin is located in Niger Delta in deep water West Africa. The Agbami Field ranks among the largest single finds to date in deep water West Africa. This image shows the exact location of Agbami oil field off the coast of Nigeria in the Niger Delta basin. The oil field is 70 miles offshore. Next, we're going to talk about the stratigraphic chart. The study area for Agbami Field consists of several stratigraphic layers: the Akata, Agbada, and Benin Formation. Several sources have validated the depth of these formations. The Akata Formation is of marine origin and is composed of thick shale sequences, turbidite sand, and minor amounts of clay and silt. Whiteman suggested that the Akata Formation may be about 6,500 meters thick. The Agbada Formation overlies the Akata Formation, and it is an alternating sequence of sandstones and shale beddings. The Benin Formation consists of the top portion of the Niger Delta Depression, from the northern Benin area to beyond the coastline. This is a diagram of the stratigraphy of the Niger Delta Basin. It includes the time period of the sediment deposition. The Agbada Formation is highlighted in yellow, and it is the sandstone, the reservoir rock, containing the oil. The Akata Formation is the green marine shale, and it is the source rock. Now we're going to talk about the structure of the field. Here is a structure map of the oil field. The contour interval is 100 meters. Here is the same structure map of the oil field with more details. We can see that there are 12 water injectors at the oil-water contact 4,500 meters deep in blue. There are 15 producer wells at shallower depths in green, and there are 4 injector wells in red. This is a total of 31 wells in this oil field. These are the seismic lines of Agbami Field. From these seismic lines, we can discern the anticlinal feature of the field. The reservoir is a doubly plunging thrust-faulted anticline. The index map is in the top right corner. We can also see the different depths of the wells on the left. 13 million year wells ranging from 8,000 to 9,000 feet, 14 million year from 10,140 to 11,253, 16 million year wells from 10,442 to 11,616, and 17 million year wells from 11,319 to 14,880 feet. These are maps of the reservoir. On the left is a time structural map. On the right is a depth map. These are seismic sections of part of Agbami Field. The information from these seismic lines comes from the time structural and depth maps that were just introduced. We can see these time structural and depth maps in the figure right here. This figure shows examples of Niger Delta oil field structure and associated trap types. The image in the bottom left is the most relevant to Agbami Field, as the Agbami structure is a northwest to southeast trending four-way closure anticline. Most known traps in Niger Delta fields are structural, although stratigraphic traps are not uncommon. The structural traps developed during syn-sedimentary deformation of the Agbada paralic sequence. The primary seal rock in the Niger Delta is the interbedded shale within the Agbada formation. The shale provides three types of seals: clay smears along faults, interbedded sealing units against which reservoir sands are juxtaposed due to faulting, and vertical seals. Now we will talk about the reservoir of the field. This is a schematic of the Niger Delta showing the distribution of depositional and structural belts. It shows the depositional environment of the region. From the mainland, we can see the pre-Cretaceous basement in red all the way to the toe thrust in blue. Our reservoir is in the white study area. Based on the truncation of the data in these logs, these can be 13, 14, 16, or 17 million year wells. This is some good log data, as can be seen by the caliper deviating very little. These two wells are drilled 560 meters apart, and the logs can be used for stratigraphic correlation, as well as to infer the depositional environment. By comparing the gamma ray signature to typical log patterns, the depositional environments of the formation sand masses were inferred as inner fan channels of deep sea settings using the modified Malcolm-Ryder log motif. This is a diagram showing the conceptual depositional model. The depositional environment is sandstone made by sandy deposits, and it is turbiditic. The model differentiates the channel-dominated area from the sheet-dominated area. The model shows low net-to-gross areas and high net-to-gross areas. This data is extracted from the well logs previously discussed. It can be averaged to representative values where API is equal to 60.97 degrees, porosity is 22.7%, net to gross is 77.5%, permeability is 1,720 millidarcies or 1.7 darcies, and water saturation is 42.6%. Now we will talk about the hydrocarbons and the source rock. This is an index map of Nigeria and Cameroon. The maximum petroleum system is that in which discovered and undiscovered fields are accounted. In the figure, it is the province outline, bounding structural features. The minimum petroleum system is that part of a petroleum system encompassing discovered shows and accumulations together with a geologic space in which the various essential elements have been proved by these discoveries. There has been much discussion about the source rock for petroleum in the Niger Delta. Possibilities include variable contributions from the marine interbedded shale in the Agbada Formation and the marine Akata Shale and a Cretaceous shale. Known reservoir rocks in Agbami are Eocene to Pliocene in age and are often stacked, ranging in thickness from less than 15 meters to 10% having greater than 45 meters in thickness. Edwards and Santagrossi, two very distinguished authors, describe the primary Niger Delta reservoirs as Miocene paralelic sandstones with 40% porosity, 2 darcies permeability, and a thickness of 100 meters. This is synonymous with the data extracted from the logs previously discussed. Rocks within the petroleum system are from Paleocene to recent in age. Most of the petroleum is sourced from the Akata Formation, with smaller amounts generated from the mature shale beds in the lower Agbada Formation. Deposition of overburden rock began in the Middle Eocene and continues to the present. Units include the Agbada and Benin formations to the north, with a transition to the Akata Formation in the deep water portion of the basin where the Agbada and Benin formations thin and disappear. The history of Agbami Field is as follows. In 1998, Agbami oil field was discovered. In 2001, appraisal drilling was completed. In 2005, a contract for the construction of the FPSO vessel was awarded to Daewoo Shipping and Marine Engineering Corporation. Acergy was also awarded a contract in the same year for design, supply, and offshore installation of a deep water offloading export system. In 2008, production of oil began. In 2014, FMC was awarded subsea contracts for Phase 3 of this project. In 2017, the Agbami infill drilling production phase began. Next, we will discuss the description of hydrocarbon in the oil field. This will be information to validate what we've already discussed. We will also talk about the cumulative production, production history, and future development of the oil field. And here is some of the data that can support volume calculations in addition to what was presented earlier. This data was recorded in 2021. The API gravity is 49.7 degrees. The net pay thickness is 219 feet. The area is 10,650 acres. The depositional environment is consistent with what was previously shown as channelized and sheet turbidites. The oil water contact is also consistent with the structure maps previously shown at 14,698 feet or 4,500 meters, give or take a couple meters and a couple feet. Consistent with Phase 2 studies, the Agbami facility capacities remain at 250,000 barrels of oil per day, 450,000 million cubic feet per day of total gas, 450,000 barrels of water injected per day, and over 770 million barrels of oil as at year end of 2017. This is a bar graph showing the phases in the Agbami project. We are currently in the Agbami infill drilling production phase, which started as of 2017. Here you can see Phase 2 startup and Phase 3 startup. The field cumulative production is tracked by global data, and this is a plot of the barrels of oil equivalent per day forecasted into the future to 2030. The field is expected to recover 133 million barrels of oil, comprised of 133 million barrels of crude oil and condensate. The development strategy for this field is very straightforward. Phase 1, Phase 2, Phase 3, and AIDP. The most significant enhancements made in Phase 3 were the development, staging, and timing, as well as fewer wells to reduce the total capital expenditure. Here is a table on the production of Agbami Field. In 2019, there were 33 million barrels of oil per year, as well as 145 million cubic feet of gas per year produced. In 2020, there were 1 billion barrels of oil equivalent in reserves. And in 2021, there were 45 million barrels of condensate being produced per year. Nigeria's Agbami oil field was the largest deep water oil exploration at the time, 2008, with an estimated 1 billion barrels of oil reserves. The Agbami conventional oil field recovered 88.79% of its total recoverable reserves, with peak production in 2011. The peak production was approximately 241,000 barrels per day of crude oil and condensate. Based on economic assumptions, production will continue until the field reaches its economic limit in 2031. Agbami development scope, Phase 1, Phase 2, and Phase 3 are complete. To offset the field decline, infill drilling continued in 2019, and the cumulative production recently exceeded 1 billion barrels of oil as of 2021. This is a diagram of the success in deep water exploration in Nigeria compared to the rest of the world before Agbami Field began producing in 2008.